Welcome to another Confluence podcast. I'm Randall Stevens, and I've got Evan Troxel here with me, and our guest today is Rob Otani from Thornton Tomasetti. I'll give a brief intro, Rob, and then I'll let you, fill everybody in more detail. But Rob is the CTO and is a managing partner at Thornton Tomasetti, and he runs what's called the Core Studio, which I'm sure we'll talk quite a bit about. But he's got a great group of development team there at Thornton Tomasetti that do a lot of great work. I think you all just recently held your infamous hackathon, so maybe we can talk a little bit about that and how all that went. But welcome to the podcast. Oh, and I didn't say that Rob participated in our full Confluence event here in Lexington, so it was great to have you here, and the group really enjoyed the conversation. So we're going to try to get this out to a broader audience.
Great.
So welcome to the podcast.
Thank you.
So maybe just a little bit more of your background, and then we can kind of dive into what your team's mission is there at Thornton Tomasetti.
Yeah, so, I'm CTO now, but I started out as a, innocent structural engineer back in the 90s. Felt like I was, pretty high-performing production engineer. And in about 2007, I believe, I was involved in an organization called SIONI, which is the Structural Engineers Association of New York, which I think at that time I was either president or close president-elect maybe. And I kept hearing about computational design around that time. And people were using something called generative components, and which I never even opened or tried. So I decided, I was part of the programs committee and decided to organize with other people that were part of the team an event on computational geometry. That was the name of the event. And we invited some people that are now pillars of the computational design industry, which was Ian Keogh was at Pure Happold, Dave Fano, and who else was there? He was at Shop Architects at the time. Dave, Josh Emig, I think, Steve Sanderson. They're all sort of the case design team that ended up going to WeWork and started other companies aside from that. Onur Gun, who's now I think he's at Reebok, I believe, but was at KPF at the time. And then, one of the I would say the fathers of computational design was Neil Katz at SOM, and Kat Park as well, who's in the San Francisco office, who I just saw. She came to our conference. So that when I saw that conference, and the things that they were doing was just amazing. I mean, it was, even today would be amazing stuff. And so I had no, even affiliation with computational design or parametric design even. So I realized that was the time, that was like a turning point for me, because I realized that I was behind the curve. I wasn't going to be the designer that I wanted to be without knowing at least some of these tools and methods. So fast forward about 2010, when in 2008, I left TT, I came back in 2008. At that time, BIM was a big deal, or at least started to be. And so I had good experience with, Revit. I had worked on, when I was at Arab, I worked on their first Revit project in 2005, actually, so it was early days. And so when I came to TT, it was a natural progression for me to just get involved with that both the marketing of using those tools, of how great it was going to be, but also just in terms of, spreading it out through the company. And then I took my first with, the other person that was formed the group with me, which is Jonathan Schumacher. Both of us took a Grasshopper class from the Mode Lab folks in Brooklyn. And, the rest is history from there. That was like, a new language that we learned. And he got great at it. I got I still am I'm a beginner effectively, but at least the point is I knew what it can do, and I know it can impact the business.
So when you all did that first year, that first gathering, did you all do it again? Did you end up doing a series of those, or was that a one time?
The classes,
Well, when you first had that group got together that first year for the computational.
oh no, that was it, and and then it opened up a whole new world actually, because in about 2010, I think Grasshopper was released, or came out into the industry. I was teaching at the time at Pratt Institute as well, and the students were using it, and I said, "Oh, that's something that I think I can get my hand around." It was very logical, it was very powerful, and but I didn't even know Rhino at the time, so for me it was a steep learning curve. But after a while, it was like this is well, it's not the only way to go, but definitely if you want to expand your capabilities, it's the way to go.
And were you using those tools initially, like in your workflows at TT, or?
Yeah. So in and around that time, we were using, because we were using Revit, because we were using some structural analysis tools, and we're using Rhino. There was these connectors, and they're still out there, called Geometry Gym.
Got in Australia, right?
Yeah. And we were using those tools, and I think the turning point was when the CEO at the time, Tom Scarangelo, one, he saw the power, but also the fact that we're able to work in unison with the architects who were also using Grasshopper. We just had to make some modifications to their scripts, and we would get the structural part, and we would work, sort of hand in hand with what they were doing. And we were doing things, in terms of getting documentation for early designs out there, orders of magnitude faster, cleaner, sort of more robust deliverables than we would ever be able to do. And so that changed the game for us.
You mentioned like you had a steep learning curve if you were to jump into this, right? But just knowing what it could do was super important, right? Just kind of unlocking or just understanding the potential there.
Yeah.
I've taught leadership, Grasshopper to leadership before with that exact idea in mind. It's not like I'm not trying to teach them actually how to use Grasshopper, right? Yeah. I'm trying to teach them so that they understand. I'm just trying to show them under the hood so that they can understand what's possible, so that they can be the enablers of the ones who are actually going to be the operators of the tools. And I'm just curious from your standpoint, like how did you take that information and how did you deliver that to your CEO at the time to help them understand that so that they would really let you guys run with it and your team, right? Because there is like you do want to match up the architectural firms as well, right? So you can deliver a higher level of deliverable back to them in a faster, but like efficiency is not the only reason you would do this, right? And so I'm just wondering from a leadership standpoint and an enablement standpoint, because there's still firms out there just trying to make this happen. The stuff that you did 20 years ago or whatever it was, right? And this is still a challenge in the industry for a lot of firms because there are so many high-tech tools that people use in firms or can't use them because leadership doesn't know what they can do and they don't want anybody, quote unquote, wasting their time trying to learn these things.
Wasting their time,
right?
Yeah. So I think it was a combination of, at the time I was a pretty well-respected structural engineer in the firm. So it wasn't like I was blowing smoke. I wasn't just a leader I wasn't a leader at all, actually. I was just kind of a, mid-level, I would say, engineer at that time. But I did have a good reputation of working on complex projects. I think years later, I was special structures leader at Thornton Tomasetti. So at least what I did say carried some weight, at least. But I think the best feedback that we received was from our clients. This is cool shit. This is amazing. We want
your clients being the architects.
Our clients being the architects. Yeah.
Okay.
And we won a competition, won a project, and I would say, if the only thing you're going to get out of is good marketing, well, that's directly to the client that's going to be hiring you. That's not the worst thing in the world either.
Right.
The fact that we're able to actually win a project was another bonus, and the fact that we're giving a better product was even better. So, it wasn't a hard sell for me, because I will say, Tom Scarangello he was always a tech first sort of leader. He was the first person with the BlackBerry, right? Even before the BlackBerry, it was a Palm Pilot.
Yeah.
Tom had the Palm Pilot 4, the Palm Pilot 7. It was like,
Right.
he always had the latest one. And then, the BlackBerries came around, and then of course the iPhones and all that. So it wasn't, he already had that mindset of, technology is business and business is technology in many ways.
You're also describing this very rational behavior of a total engineer, right? And, and I'm thinking of like architects who we think we know it all already, and there's nothing new under the sun, and so maybe it's a different argument for a different ear to actually hear it in an architecture firm, but the way you're describing it, it's a no-brainer, right? It's like I think a lot of architects still struggle with this. Yeah.
I mean, yeah, and I know what you're saying. I will say, I taught at an architecture school for 10 years. And there is a different, architects are made differently in many ways. But if you break it down into a business, use case, then it becomes very logical. It's marketing, more projects, better workflow. It's hard to argue about.
Kind of ticks all the boxes, right? Yeah, I know.
It does tick all the boxes. And
right.
Now I will say, computational design is hard to scale. That's where you need to do it at the right time. It's not for every point in time in a project. I think that's even now. That's still something that we strive to work on, is because it's not taught in college, at least for engineers. Architects actually are better prepared than engineers by a lot, actually. So, we had to sort of find the right people, the right mindset, who are going to leverage the technology, because it's one of those things where engineers like to solve problems. That's what we do. Mm-hmm. And so in many ways, when you design parametrically, you're just solving a problem in a different way, in a more data-driven method, as opposed to, an engineer likes to say, I know the solution, this is what I'm going to do, that's the right answer. But the problem is that the architect might not like that answer, right?
True.
So then you have to adjust your design. So, I would say it's still a relatively small percentage of engineers who know, how to work that way, but it's changing. It's getting better.
Rob, can you maybe bridge us, or what was the evolution from your beginning to, do this work internally at TT, and the evolution of what became the core studio and kind of more investment in these directions?
Yeah. Well, as I mentioned, it started with before it was core studio, it was a team called Advanced Computational Modeling. Very small team. And we started, I would say around 2013 or so, an R&D initiative in the firm. And it was kind of, at the time it felt only natural that, it would be at least funnel through our team, the R&D part. And I will say, I had to give credit to the guys from AEC Hackathon. I don't know if you remember those. I don't know. I think they still do one, Copenhagen Hackathon. They did, I think it was their first one, AEC Hackathon in the Facebook headquarters in San Francisco. And I sent 3 or 4 of my team members there. And, they came back like kids from a candy store. It was like, they go out there, first of all, maybe some of them probably haven't been to San Francisco, so that was fun by itself. But then they met all these like-minded people. They came back with
it's a Burning Man. It's like they found their tribe, right?
Yeah. So we still have some videos out. The funny thing is their hackathon was to take an Excel spreadsheet and move a dot from one point to another point through on the web. That was it. So they learned the web. That was 2013.
Wow.
And when they came back, again, I didn't go, but when I heard all that sort of commotion about it, I said, why don't we do our own? So that's how we started our conference and our hackathon was from that initial one. And to this day, it's still like that same feeling, of finding that, like a Burning Man. It's kind of like the AEC Tech Burning Man.
Yeah.
And I think it's a significant event because it's sort of anything goes. It's one of these things that's not around any particular technology or idea or company initiative. It's very, crowdsourced in many ways.
Yeah, you don't direct the topics, right? They
No.
come from the other way around. Yeah.
No, and I will say, I even mentioned it at the end of the hackathon a few weeks ago. I don't know how it happens. So we have something called, when we start the event, we have something called the lightning round. And anybody, again, most of the people don't know each other. So there's 100 people in the room, nobody knows each other, and they just get up there and say, hey, I wish I could do this. I don't know how to do it. I wish I could do it. In about a span of 15 minutes, 34 ideas were discussed. In the next 15 to 20 minutes, 8 teams were formed. I don't know how it happens. It's like a psychological petri dish of, behavioral petri dish. I don't know how it happens. It's just organic. It's just like people start going in clusters and away they go for the next 20 something hours. It's amazing.
When you started the ACM group, the Advanced Computational Modeling group, it sounds very purpose-built, and it sounds very much in service to the design teams in your office. But then the shift to opening this up to R&D, which is open-ended, right, potentially, and then hackathons and things like that. How was there a conscious shift, or was you just like, oh, this feels right? Or like, how if you could kind of put your thumb on that, what was kind of what was the trajectory there?
Yeah, I think each moment was a little bit of a learning process for us. So, started with computational modeling. We saw how powerful it could be on projects and how it was something that if you're been around engineering for a while, it's something you've wanted to do over the years, but just, the architect says, I want to know that do this. Well, I can only do this in this amount of time. This is what you're going to get in a way. And then you feel bad about it because you probably could have done that if you had more time or whatever other meta methods. So part of that ACM group was that we also did training, by the way, as part of that initiative, because we didn't have projects. The interesting thing is about computational modeling probably only happens in about 2% of a project timeline, but it has a huge impact. That was always the promise, and that's, if you do it right, that's how it works. Maybe it's 5%. So we ended up training a lot of people in that time period. Not everyone's, it's interesting. The people that gravitated to it didn't always stick around the company. They were the forward-thinking people, and they started their own companies or did some other, wanted to do other industries. It was interesting that way, but that doesn't mean that you don't do it, right? Yeah. That just means that maybe this industry was not meant for those people that are gravitating towards advanced workflows. But the ones that did stay, became extremely valuable for us. So the transition into R&D, I think, was more from the top. That was, I think, you have to think about what was happening outside of our industry, which was the Googles of the world and Facebooks and Amazons, that there's something else out there that our industry, is always kind of slow to discover. And so, I would say we always did some level of, project level R&D and try to move that forward. But it was, I think, the CEO and leadership at the time realized you're not going to move the needle by, trying to just scrape up some good ideas and move them forward. It has to be a holistic concept within the firm. And I think I'd also at a similar time, we were the company that is was having these every 5 years. We have these 5-year plans, and it's meant to look, pretty far out there. 5 years is a long time in our industry, and so I think if you want to be, again, our mantra, I think it was developed around that time, was to be the global driver of change and innovation in the industry. Well, you don't do that, from taking, some cool ideas from a project, moving it forward. I think you have to invent, some real innovative ideas. And so that's, I think, when it became formalized. It was around 2014, I think. And I remember some of the first ideas was using drones in construction. And we actually use it on projects. It was one of those things where like, oh, why not do inspections for using drones? It was pretty simple, but at that time, pretty novel. Another one which is still in existence. It was this damper technology that is now called a separate company called Hummingbird, that someone came to us, I think, it was from NASA, and said, hey, you guys might be interested in this damper technology that we use for, rocket launchers, and we could apply that to a building. And it's a separate company. It's called Hummingbird Kinetics. So yeah, I think that was a significant transition to formalize innovation, if you will, in R&D. Blue sky R&D, not something that is, structured. It's kind of unstructured R&D.
I'm assuming you had to pull together an original team, and you got a budget approval from the company to get that team. What did that initial team look like when you all started?
So, and Evan probably knows this. Here in New York, we had this funnel of 8, I would call them A&E and software developers from Stevens Institute of Technology. It was, again, Nate Miller, I think, I'm trying to think, a lot, again, I can't name all the names, but a lot of people came from that school. And so even now we have a few here. Actually, my senior director, Alex Pollock, also was from Stevens. We started getting those folks. And they were an interesting group because most of them were architects who went to, this master's program at Stevens Institute of Technology called Product Architecture, which was a combination of architecture, engineering, and software, which was exactly what we kind of wanted. We wanted this sort of the mindset of an architect of solving hard problems, structure of an engineering mind to, figure it out in a way, and then the software part to stitch it together. And, that worked out really well for us, I would say.
Can you talk a little bit, Rob, about, I know you all obviously develop some of your own tools internally, but you also team up with other outside software companies and do integrations. One, how do you all think, how do you think about when do you build versus go, work with somebody or help direct something externally? And then maybe a couple of examples where you all done that successfully.
Yeah, we don't do a lot of external outsourcing. One, because that's in many ways, when we do, it's sort of something that we know we can do, but someone can do it faster or better or cheaper. And there's not that something innovative within that task. If there is, then we do it. Because, if you hire someone to do something that we may not know the answer to, how to do it, then it becomes a scope problem, additional change orders or whatever.
And you lose that learning that happens during the process.
Yeah, that's the fun part for a software developer, right? Is to learn something inventive in that process. So we don't do a ton of it. We have done it with our Construe platform, which is a separate company now. The hard part about software is that, particularly web development, is that in 5 years you got to rewrite it. just things get old.
Yes, yeah.
And, data structures change, so we've had to rewrite a lot of that stuff, which is good. It performs better. But it's a tricky process, right? You got to make it seamless for the end user.
So was that part of y'all's mission, Rob, to not only develop things that would be used inside TT, but commercialize those? Because your mission of wanting to change the industry, I would think that's goes hand in hand with, it can't just stay here if we really want to.
I think the answer to that is yes. I would say the focus is internal, but if something like Hummingbird, like Construe, comes out that we see potentially a bigger benefit externally, whether it's from a monetization standpoint, or whether it's just not the exact fit for Thornton Tomasetti as the engineering firm, then yeah, there's always an option to get it out there.
Is that driven by, somebody worked on it, wants to see it through, and petitions to kind of spin it out, or what drives that?
Again, I think it's a business decision. Construe, there was a series of companies. So one was called T2D2.ai, which is a computer vision tool that does autonomous building inspections. That one, we do building inspections, but if you really wanted to scale that application, it probably shouldn't be internal. It should be external. I think the people that decided to spin it out saw a huge potential in where that could go. I will say this, that one of the lessons that we learned was a lot of the technology that we've developed has been ahead of the curve, which is not always great for software. And I'm sure you as well from your standpoint.
If you're educating the market, right? It's like
you kind of want to build something that people need at that particular point in time. But that doesn't mean that it was the wrong thing to do. It just means that it was solving a Thornton Tomasetti problem, may not solve everyone else's issues at the time.
AI obviously carries lots of buzz. Everybody's got it somewhere, says that they've got it somewhere.
Yeah.
But maybe you can describe a couple places where you all are implementing or using machine learning, and just where you see that going, and how effective it's going to change some of the things that you are working.
Well, maybe I'll tell you the story how I got behind it. It was around 2015. We had a relatively small development team, and one of the developers on the team would always talk about machine learning, and I was like, "What's this machine learning all about?" And then when he told me about the fact you take some smart data, use some algorithms, data science to train something that knows everything about what's in that data set, and then sooner or later it gets good enough, you just ask the question and it gives you an answer based on those previously solved problems. And I was thinking to myself, isn't that what we do as engineers and experienced engineers?
Engineering? Right.
That's engineering. But that's architecture. That's anything as a human, right, over time.
No, not architecture, Rob. Sorry.
Not architecture. Parts of architecture, let's just say. Parts of architecture. So yes, engineering is more specific in that realm. But so that got me excited, because that means if you do it right, it becomes a significant sort of tool for knowledge transfer, like just knowledge. Even if it's just an application, it's like taking the company's best Excel tools, instead of having everyone has their own, right? Aggregate them. Let's create one or two, say, and then everyone has the same thing, or not rebuilding them over the ages of time. The other aspect of that I saw was, and I was at a conference last week, and it sort of dawned on me. It was, probably maybe more, 70 to 80% of every project that we do has been done before, like literally done before. Whether it's, if you break it down into its components, whether it's a foundation, a column, a beam, or slab, core, it's been done before. So why are we spending months, years sometimes redoing the same thing? Almost the same thing, I would say. And that's the promise of machine learning, is that you aggregate those solutions to give recommendations for a particular project when they need it, as opposed to reinventing the wheel every time, which is what we do actually. If someone asked me about a project we did 10 years ago, maybe I can ask 5 people that may have worked on that project. Their memories might be fuzzy, but we don't even do that. So there's no sort of, so in many ways, so what's the value of a company if you can't, take past experiences and move them at the project when you need it at the time? So, that's the big picture. The smaller picture we're doing is just creating these little micro apps that will save some time, during particularly schematic design. And, the other thing, the correlation I made at that presentation, was what we did when I first started, which was in the mid 90s. We didn't have computers at the desk. So we had to do everything not all by hand. We had shared computers. So we would do like Excel spreadsheets over there, or, there was a few engineering apps, DOS programs and things like that. But the rest of it was very much person to person, and you would use past project data for what you were doing. So we had, and I still have it actually here back in my pile of mess back there, all these little single bay design apps for office buildings and for other types of buildings. And so, an engineer would do one, they do it at nice, and we had CAD at the time, so you can do it in CAD. We had an army of CAD drafters back then, way more technical, like drafting staff than relative to what we have today, because engineers and architects just do it now. But point is that once we did it, you never did it again. You go to the book, and a good engineer can design a building without doing almost any analysis. But so in the last 15 years, the tools are very good, from drafting tools or BIM tools to analysis tools, to the point where they can do the entire building from every part of the building in, probably days or a week or two. But the point is that once you do it, it's very hard to change those things. And arguably the designs are not that much better, because what you're doing in those early phases is just constantly, I would say, responding to, potential modifications. It could be a cost issue, it could be a coordination issue, it could be a complete design change. And so, why are you designing a whole building when, the 50% of the building is going to change? And so that's sort of the, what I use as a corollary to what we did when I first started, which is a very data-driven approach to what machine learning can do, in the future.
From kind of a disruptive standpoint with software and with machine learning and like encoding knowledge, was it really seen as disruptive potentially to the future of an engineer's workload? I'm just curious how you guys kind of saw that, or how you pushed through that in your offices.
No, we're still pushing through it, to be honest. But what it is engineers are taught to be, I wouldn't say wary, but, question what's put in front of them. In fact, we generally tell engineers that they need to Excel, even with someone gives them an Excel spreadsheet, to check it. And so machine learning is very black box. You don't see any of that. Mm-hmm. It's put some stuff in there and something comes out. So, what we've been saying is, okay, we made this app that does this. You should use the app only after you've, done it in your own methods, or conventional, what I call conventional methods, commercial software methods, so you can get comfortable with the level of accuracy. Once you get there, then you don't need to push those 100, 200 buttons, to get that answer. The answer is there. Even better is when we get ideas for creating another app. That's sort of, we kind of want to create this culture of, continuously improving the apps that we have, and then suggesting new apps for the future. We know that in our team that we don't have all the answers. We're relying on some, the most widely used types of tools or use cases, and then, but there's always something that, either sometimes there's different regions do things differently, or so there's going to be a lot of flavors, I think, over time, even doing the same thing, same apps.
Rob, when we did the Confluence event in Brooklyn back in April, you sent a couple people from your team, Omid, Sergey, came and presented. Yeah. They spent some time, explaining the story of, I guess the gentleman's name was Mike, that you all did a project where somebody that was longtime leader inside the firm passed, and but you were able to drive a project that was like a collection of a lot of information that he had left behind. Can you maybe tell us that story and where that stands? I loved this whole idea of like capturing, you said it earlier, capturing knowledge and then having that live on has a lot of appeal.
I'll tell you the story, and I will say it's not going to be easy for everyone, but it was easy for Mike's conversations and data because of how good he was. But so back in 2022 or something like that, one of our Omid actually had an R&D project with the R&D program to train a model to learn the building code. That was, or at least find things in the building code. And, we were going to create something custom, and all of a sudden an OpenAI comes out. So he created his own little web app that, uses the OpenAI API, foundational model, points to indexes, I think we actually did index at building code. I don't do that full time because I don't know the legality of that, I think, but we just did it as a test case, and it was amazing what it could do. It basically reads through a PDF in seconds, less than, and then gives you an answer based on that. We also did some other AI, which was to sort of explode, if you will, all the tables and charts, which are frozen in PDFs. So they're extracting the data that's within those tables that are generally frozen. So it was really good. I mean, it was finding everything that we wanted. So, and we had different use cases. We're indexing our intranet, which we call Spark. It's sort of the internal sort of, intranet of, we post, technical information, resources, but also just fun things. And then it showed, a lot of promise for that because it was finding things that the internal search engine to that application was just absolutely terrible. It was finding things not just from the beginning of time, but also in chronological order, which also is very valuable. So Mike heard about it and he said, hey, I got 10 years or so, or maybe 7, I forget how many years it was, of emails, because in the last, I think it was 7 years, because in the last 7 years, he wasn't actually working on particular projects. He was just an internal resource. He used to be our sort of site, engineer, just to, solve all the problems before they became real problems. And he was just so knowledgeable about primarily steel, but pretty much anything that happened on the site as related to structures. And so in the last 7 years, he was just a resource. Anybody can ask him a question about, steel or anything on the site. And he saved every single email judiciously. And the other part was when he answered those questions, he didn't just give them an answer. He said, based on ASTM, blah, 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 and AISC, this, that. So it was very like robotic in a way, right? Like almost like a Turing, sort of response, if you will. And so, okay, we decided to take that. He didn't know how to do it, but he asked me to do that. So we took his emails, cleaned it up a little bit, because you don't want all that stuff to date. Well, maybe you want to date, but we cleaned it up, and we had him create 30 questions, like tricky questions that, not everyday stuff. And when OpenAI responded to those questions based on that data set, we asked him to rate it, and he gave it a 4.7 out of 5, which, as
total engineering number.
Yeah, it's very, in a way, that's very data driven as well, right?
Right.
But that was the only method that we could think of to say, okay, this is good or this is bad. And his 4.7 is like, is way better than anyone else's 4.7. So even now we have, and unfortunately, 6 months after that, he passed. And, so, again, we actually, so, our ex-CEO and a couple of others went to his funeral, and we did start or assist in creating a scholarship in his name at his university that he went to. And his name is Michael Ashmit, by the way. And we decided to take that data set. We got permission from his family's members to use it, for the rest of eternity. And we still have that sort of, data set, if you will.
In a way, he's living on, right? Like that's a pretty incredible resource. And like you said, it's not easy for firms because not everybody did what he did or does what he did.
Yeah.
Which I think is a key part of that as a good disclaimer for you to make up front, because a lot of people don't go through that rigorous process of cataloging that information along the way, but that's kind of what you need to build a mic tool, right?
Yeah.
So was he a teacher at Harvard, Rob? So like, he was explaining why.
He was so smart, very, very smart people sometimes can get short and, give short answers. But he was not like that. He would go.
He had citations and footnotes.
Yeah.
It was incredible.
So not there's only a few mics out there, but there's a couple issues there that if you think about it is not, one, it's not creepy because, that's the first people think, oh, it's creepy to use someone else's, it was past. But it's not, because that's what we do all the time.
Sure.
When we have a conversation, we work with someone for a long period of time, it's inevitable that person's sort of learnings and teachings, I should say, and you don't know what's going to come through you, but it does. I still remember things that Charlie Thornton said, or Richard. Actually, that brings to the next point, which was, if we can do that now, then it makes it even more important to catalog knowledge in a way.
Sure.
So you're not going to capture everything. Like, it's impossible.
Well, I think, part of that discussion that we had back in April with Homid, after they gave the presentation and we kind of opened it up for conversation, it was one thing about machine learning and AI is usually you're thinking about that being on the data that you're going to learn from is usually an end result. And I thought it was very intriguing to think about that what you're missing from end result is the process that led to the end result, the why, right?
Yeah.
That's harder to capture, but those emails and that explanation, is how you learn. And, in today's environment, when you get, especially if young people aren't even coming into an office to be mentored,
it's
right. It's a whole new world, right? About how are people going to learn why, and it's always through stories, and all this stuff is passed and absorbed over time
through listening to your supervisor yell at somebody over the phone, right?
Well, I'd given the example when we were at the Confluence event talking about this. I was like, I'd had this same conversation. You know, I have a degree in architecture and been involved with the school here locally over the years. And I was making an argument about like that the real value of the education is probably the desk crit. So it's like, why don't we drop a recording device, an orb, right? That's like, it's red, so everybody knows it's there, but you're going to like record this. And it's like capturing that conversation between the student and the professor in the studio time, to me is like, that's where the actual learning happened. But at each desk, it's only 20 minutes at a time. But if you could take and capture all of that and put it into an AI, engine like this, to me, that's like a very intriguing, sexy kind of thing to think about happening.
Yeah. And it may not have value until you have, 50 desk crits.
Right.
Right. But there will be value there. Right. I was thinking about it. What's actually hard about machine learning or building new models, let's just say, is that, when I explained that, Mike very clearly explained his rationale. Humans do a terrible job of that, right? Sometimes they get to an answer, they don't exactly know how they got to an answer. So, how you decompose a response to a series of problems, in a way, your mind has the most powerful parametric, modeling software in the world, and is doing all these calculations based on past experience, past failures, past wins, all these things. And you come to an answer. You don't exactly know how. And so that's why, particularly, to your point, Evan, about architecture, it's much harder to train models on architecture because it could be a look from a client, or it can be a look from someone who's judging your work. Has nothing to do with logic or had nothing to do with the design, actually. Right. So that's very hard. And that's why I don't think AI is going to take over everything that we do, because there's a human element in there that call it illogical behavior that is
emotional.
So anything that we do now, architects are doing, early design studies using past imagery. It's kind of like precedent study and, automation, if you will. But it's really good, and it saves them times, and it potentially sometimes spurs new ideas. So why not do those types of things?
Yeah, it seems pretty obvious to me that it's going to be a companion, right? It's not.
Yeah.
It's going to help either, like you said, accelerate how quickly you can get to an answer, or it's going to spur you in some new directions.
I mean, if you think about even the tech companies now, right? Whether it's autopilot or self-driving cars, or even what Amazon does or Instagram, that's easy stuff, if you will. It's like, if this, then that, then it's this, then here's the answer. What we do in our business is way harder than that. And, look, recently, Zillow.com tried to automate, real estate. They failed miserably because real estate's not just a series of boxes and numbers. There's people have depending on who that person is, they're going to have a different idea about what some value of a house may be. Or sometimes it's just the salesperson can pitch us a sale better than another person. And they lost their shirt, right? They had to quit that.
They were trying to do arbitrage on buying and selling, right?
Yeah.
They lost. Yeah, they lost that bet.
They lost. So that's because there was too many factors in that use case and they didn't have the data that driving those answers. So I think the idea with AI, at least for now, is to focus on the things that it can do well, and then we figure out how far we can push it down the road.
You've got quite the team now that makes up the core studio, so maybe you can give people kind of a sense of scale, the team, and then maybe just a glimpse of what you are working on now, or what you think is right around.
Yeah, it's about 40 people now. The majority, I shouldn't say the majority, about half of them are software developers. We have. So I'll mention the verticals. So we have an app dev team, a core modeling team, which is kind of like the continuation of the advanced computational modeling team. Data and knowledge So we have a team that's sort of cleaning our corporate, information, both data analytics and AI. A BIM team, and something that we call core delivery, which is more on the fabrication, design and fabrication side, Tekla and things like that. So, yeah, I mean, I think the big initiative for that team is to make technology just part of our everyday process, not something that is a bolt-on, if you will. It's like what we want to do is the day they walk in the door, they get introduced to it, trained on it, and then it just becomes part of the process. It's just a normal delivery. And if we know that if they do that, we can achieve that we'll have a high-performing team. Oh, I should mention we have the AI team, which is really part of the app dev team. So that's the other part. I would say the reason why I sometimes miss that is because the AI team and the app dev team work hand in hand. You can train all the machine learning models you want, but if you can't spin it up into something that people can use, it doesn't do anybody any good. So we've built all kinds of tools around just the infrastructure of releasing machine learning models and storing models, and experimenting with models. So yeah, I think we've gotten big enough where we have to start to prioritize now with what we do, because if I had my druthers, we'd be 40 people, but we're not. So we have to focus on effort and impact with an eye on the future. I think that's critical, because if you just focus on effort and impact, you're going to solve the next 1 or 2 years, but not forget about the next 5 or 10. So we have to kind of continue to do that, and which is why we do the conferences, because I think that's a good way to reset and see where we are, and maybe we have to change direction a bit based on where the industry is going. That's why I go to events.
I'm sure it's helpful for recruiting too, right? Just to, again, find the people that are
absolutely
interested in it.
Yeah.
I was just going to say, it's first of all, thanks again for participating in our Confluence event this past fall. It was great having you here. We had a good group of people.
It was fun.
Presentations. Yep. And then, thanks for putting on doing the hackathons. And I think it is important to get these like-minded people excited and out and thinking about these things and working on them. It's an important part for the industry. And obviously, Thornton Thomas said he's a structural engineering firm, but obviously the works hand in hand with lots of the architecture firms. Evan and I are closer to.
Yeah. Look, and if I were to say, one thing that I think we need to do a better job of, not just us, but across the sort of, technology space, is creating apps that benefit all of us, as opposed to just the engineering firm or just the architecture firm. I think if we start to create apps that, impact the entire process of design and delivery, I think then we'll start to make some real impact, in the industry.
Yeah, I think the first time that I became aware of what you were doing was when, I can't remember who it was exactly. It might have been you, but at one of the USC BIM Bops, we talked about Asterisk and it being kind of this web app, right? That you could throw a Rhino massing model at it, and it would spit. You could say mass timber, concrete, steel, right? And it would give you information back. And as a designer, right, as an architect, it would be okay. I'm way ahead of where I would have been without this tool, and you're sharing that ability with me to do that, and then it enhances what I'm doing. But if it comes back to you as a step in the process, you're way ahead of the curve as well, right? And so just to really speak to what you just said about going outside of your own silo and creating useful software for the industry, I mean, that speaks to that directly. So that's really cool.
Yeah, by the way, that app still works, and that was I still think it's an amazing app, but it was too early, too soon. Engineers were like, holy shit, this is totally black box. I have no idea what's happening.
Can't trust it, right?
No, you can't trust it. But it was doing, 3-person weeks in about a minute.
Yeah.
That's what it was doing. I showed that in a presentation as well. We have a newer version of that. But that application would be used for like 2 hours in a project. That's it. But you would, to your point, you would be that much smarter, that much further ahead. and we wouldn't have to churn through 10 iterations.
Right.
That's the idea. And, it's one of these things where, like, sometimes you have to disrupt yourself, to make an improvement. If we stick with exactly what we've done year after year after year, we're never going to improve, how people communicate with us or how the project goes. So that was Asterisk in many ways is a disruptor, but it's a good one. I think it's more what the team needs.
Nice.
You can think about it. Imagine if we had all the other things: mechanical, electrical, plumbing. I mean, it would be pretty amazing,
Yeah.
And architecture for that matter.
Great. Well, thanks again, Rob. This has been a great conversation, and it's always fun to watch, not only what you are doing in the studio, but obviously hosting these events and getting others out and young people interested in, everybody coming out of school now, like you said, a lot of them are already using Rhino and they're using Grasshopper and Revit and Dynamo and all those types of things. So there's at least the audience is a little prepped as they come out a little more than they were, 10 or 15 years ago.
Right.
Yeah, it's been great having you join us. We appreciate it.
Thanks for having me.